مم.
دكتور، لو حضرتك جاهز احنا نقدر نبدأ دلوقتي.
جاهز تمام. مم. المفترض ان اول ما صورتي تطلع يبقى ابتدي، مش كده؟ قريب تأخروا ربع ساعة يعني.
دكتور، في أي مشكلة أساعد حضرتك؟
لا ما عنديش مشكلة، أنا منتظر تقول يبدأ.
أنا قلت لحضرتك تبدأ. حضرتك
قول.
جاهز؟ إحنا ممكن نبدأ.
أنا أوكي. لا لا لا، ده أنا قلت إن لما تطلع صورتي بدل هاكاثون أفترض إن كده يبقى أبتدي. يعني دلوقتي أنا على الهوا ولا إيه؟ أيوه
بالظبط.
تمام. آه.
تمام.
متأسف على هذا الوقت اللي ضاع مننا كلنا. في الغالب إن سوء تفهم من عندي إنه افترضت إنه لسه ما ابتديناش. بسم الله الرحمن الرحيم. السلام عليكم. This session is about artificial intelligence as a vital tool empowering innovations for national development. I'm Assam Metwalli, Life Senior Member IEEE, and CEO and founder of AI Tech for You. Life Senior Member IEEE means that my age and the years of membership in IEEE is 100 years or more. So now we are talking about big numbers. Yeah. AI Tech for You, just this is not ready to introduce AI Tech for you by any means, but rather to show the AI environment. Of course, the topic is about AI, and the AI environment. We have the provider of AI products and services and solutions, and that's where the innovation actually more come in. And of course, we have the end user who try to identify the requirements and needs and see how they take advantage of AI. And in order to make this to happen, system integrators, in most of the cases, especially if the providers are not large companies, would help to implement such new innovations into the real world, whether organization or enterprises or personal applications, for example. Before we go to AI, we just will go through the evolution towards AI. Of course, we can see that the universe is very long ago built up a billion of galaxies, and each galaxy has billion of stars. And the Earth is created 4.5 billion years ago, and the modern human are considered, of course, I'm talking about what the researchers and physicians say. Modern human is 360,000 years ago, and agricultural civilization started almost 12,000 years ago. And we can say that the history of civilization is really the history of innovation. Then we can see that the modern science civilization started almost 400 years when actually the printing took place almost, and the industrial civilization started with the first industrial revolution and second industrial revolution for the steam engine and petrol cars, electricity. And then lately, let's say the 1960, 70, then the integration of telecommunication and information technology, which the marriage of telecommunication and computers made the second revolution, industrial revolution. And then the third industrial revolution started in the 70s, where telecommunication and computer, and then along with the internet and so on. This probably Graham will summarize the whole story towards going to artificial intelligence. In the 70s, most of the technologies actually were developed, where the packet network and which is the origin for the internet, and as we mentioned, telecommunication and computer, and started for automation of many services. And then in the 90s, with the internet, we started to see e-health, e-education, for which is the use of internet to provide services. And then in the 80s and in the 90s, sorry, and 2000, then with mobile technology, started to have some mobile services. And in the mid of 2000s, 2006 or so, then it started to have U-City, which is ubiquitous city that started in Japan and Korea, making use of sensors, more or less RFID sensors, to have actual interaction between that technology, telecommunication, and things. And then this started to materialize more 2010 and above, with the introduction of smartphones, and with their application and the technologies around it, as we can see, cloud computing, Internet of Things, and all this started 2010-12 to make really the beginning of the fourth revolution, where we had those many applications that we are almost using now in more advanced way. And then the last 5 years, actually, artificial intelligence started to mature, and along with other technologies, are making the fourth industrial revolution. So we are focusing, of course, on artificial intelligence as a new tool for innovation. All these previous innovations was more or less going smooth, more and more gradual, and artificial intelligence is making it more disruptive, if we can call it. So artificial intelligence as innovation tool, it's actually described as both general purpose technology, and they define it as invention of a method of invention, which differentiates itself from normal technologies, that it is a tool for tools, if we call it, because it makes a possibility as a tool for making new innovations, which is really the purpose of this hackathon. Almost is innovation, how we can innovate for new application products or services. So artificial intelligence is a very important tool, and that's what we are going to describe and see in the next slides. As just an example of a possible tool, for example, the MRI as a technology, as a tool, it resulted in making actually outcomes for many other type of innovation. So a tool is used to make more innovation, but a general purpose technology is like AI, is to make applicable for all type of fields and sectors, and that's what we are going to see also. So, but the purpose of this presentation is really to describe artificial intelligence, its principles, capabilities, and types and categories, to have more understanding of how this tool will help us in innovation. And this tool has its own tools and procedures that actually can implement and execute innovations. And then we are going to see a number of examples of AI-based innovations in different fields. So artificial intelligence can be simplified as having the machines to do what the human is supposed to do. So the capability of a machine to perform like the brain of the human. And that's by equipping mathematics, let's say, in the model of the machine, and train this mathematics through algorithm in a way that makes appear to perform like the human brain. So that's artificial intelligence, having the machines equipped and more or less programmed, if we call this. Of course, it's not programmed by conventional programming, but programmed by examples of data to adjust the parameters so that it can perform like human brain. This describes how human brain actually is working, and the method of artificial intelligence, as we shall see, that implements this type of brain-like performance is called neural network, which, and it's or deep neural network or deep learning, so that because the brain actually is built of layers of neurons. It amounts to some 80 billion neuron or 100 billion neuron. Each neuron is connected to hundreds, thousands of other neurons. So you can imagine how such a network is complex to perform actually what we are going to see, how the functions that the human is performing. So the function that, as we mentioned, that artificial intelligence is designing machines that resemble human performance, such that it can see, and the machine can see or can hear or can talk, can perceive the environment, can understand context, as you can see in ChatGPT now, a very good example, analyze and conclude and make decisions, memorize scenarios, learn and improve, understand impressions, emotions, and behavior. This is advanced type of artificial intelligence, and plan to achieve goals. And that's really what we are trying to do when we make innovation in order to achieve objectives. So AI capabilities that are based on such and features of the brain in the machine. So the machine can then make predictions based on very large number of features, in thousands, millions, or even billions of features. So of course, normal human can never actually think of such capability, as we should see, for example, in drug discoveries, and make an insight from very big data. You know, the reason for artificial intelligence actually that appeared only now and not before is that now we have the processing capacity that can process this very large number, very large volume of data, and also the emergence of very large volumes of data resulting from telecommunications and services and social services. And so the amount of data that's coming up to take value advantage of was more or less catalyst to have artificial intelligence as a tool to deal with this data. So as we saw in previous slide, that the evolution of technology led to artificial intelligence, solving mega parameters formulas of nature, as we would see in examples, chatbots, robot on site and making assistance. So these are an example of generic application, talking languages and translation, understanding and drafting texts and stories, as maybe many of us maybe now are playing with ChatGPT, facial recognition and impression recognition, facial impression recognition, reading impressions and emotions, autonomous mobility. All these capabilities we can be actually combined in parts and pieces to result in new innovations and services. The principle of operation of artificial intelligence can be summarized in this simple figure, just to have a feeling of what we are doing when we are using the tools of artificial intelligence to make, to write a program, to do something, to be able to implement applications or so. So machine learning, as we mentioned, that we have the machine, we train it. The machine is actually including mathematical formula. You can imagine the very simple formula of, for example, we can say if you have 3 variables and 3 equations, you can have closed form solution to know this, to identify these 3 variables. But if you have thousands or hundreds or millions or whatever number of variables, and then if you have the number of equations much greater than the number of the variables, then you can actually get, you can identify those variables. So in effect, we are training the machines, which is the mathematical formula, with examples of measurements of what we are trying to achieve. And this measurement, we see how the model will respond to it, what will be the outcome, and compare it with the actual output that we know. Then we can have an algorithm that identify how to change the parameters in such a way that reduce the difference between the actual which we know and the output of the machine. So in other words, the machine will be fed with data, and that's we say that, okay, we must have data that actually can program the parameters of the machine in such a way that it provides us with the required output. Of course, the formula here will depend on the type of problem that we are trying to solve or output that we are trying to get. For example, if we wanted to program the machine to know the price of, for example, a house or something like that, based on tens of parameters, for example, and then if we know the price, then we see how the machine will be able to predict the price based on the parameters. If this prediction is different so much, then the algorithm will try to modify the parameters so that it becomes close to the actual output. So this is the general principle, let's say, of machine learning, of how we use the data which to program the parameters of the machines to give us the output that we expect in the best possible way. So having said that, then we can see that we can imagine so many applications where actually we have data and we would like to find what is the proper model for the machine and what is the algorithm that actually can help us make the machine have the output that actually expected from the inputs as we have trained it to perform. From this principle, actually, then there are so different forms of machine learning. Artificial intelligence in general can be defined as different branches: knowledge-based artificial intelligence and machine learning artificial intelligence, the one like what we described. And part of this is deep learning, which we said that it's similar to the behavior of the human brain. And different types of machine learning that for different types of problems. We have supervised machine learning, which is actually the majority of machine learning. It's almost like the one we just described. And unsupervised machine learning actually can give us the capability to make classifications, which mean that if we feed the machine with inputs, it will be able to say, this is a person, or this is not a person, or this is a cat, or this is a fraudulent type of application, or if the data is for imaging, we can say, oh, this customer, this client has disease or something like that. So this type of classification under this supervised learning, and also supervised learning, we can have semi-supervised, and we can have for supervised learning, we can have to predict, for example, as we mentioned, value of a house. If we feed the data and that program the machine to be able to predict, and then we give it any house with different type of features and parameters, then it can tell us that, for example, that's the price of the house. And unsupervised learning actually it makes more or less clustering. If we don't have, if we can just look at something and then would like to see what are how things are similar in look similar in this particular, then it can actually segment, for example, let's take customer into group of customer that seems to be liking a certain type of product, or so choose for segmenting type of customer. In order to implement machine learning, actually we have to go through this process. Of course, first we have to define the problem for machine learning. In other words, we must find that what really problem that we would like to solve, and what data is available that can help us to solve this problem, because data is what is going to program the machine. We can say that actually the artificial intelligence is really trying to gain advantage or value from old experiences, which means the data that we have in the past that reflects certain experiences and knowledge, and have it in a machine that acquire this knowledge and experience and capable to perform like a human having this capability. So the first thing is to identify a problem, saying that, okay, this problem can be solved by machine learning, because we have, for example, data about, let's say, in the banks, about fraudulent customers. And they look like that, they look like that, good customers look like that, and so on. So this data, we can see that, okay, we are going to define a machine or program that can look at this data and then have it adjusting the parameters of the machines so that it can identify the good customers and the bad customer, can classify them, can say, for example, customer who does this and that and that and that and that is good. Customer who makes this and this and that and that for 100 of features or parameters, then it's good or bad, for example. Then it can, then we say that, okay, this is a machine learning problem. Then we can promote it. Then we take the data. The data can take different forms. We have to put it in such a way that is understandable by the machine, and we can clean it in a way to make it suitable. For example, take repetitive records or missing records and things like that. And then we take this data and program the machine. And after that, we can have a product that detects, for example, fraudulent subscriber, customer in a bank, for example. In order to develop a product, we need, of course, to have hardware and software. The software is more or less what we just described, is the data that will program the machine. The hardware, depending on the type of the problem, possibly we can start with CPU just for the proof of concept or a small model or so, but very likely you may need graphical processing unit, GPU, or tensor processing. That's unlikely, but then depending really on the application, and you can actually consider if devices, for example, that we are using will be equipped with the processor to become edge device, or we have a server that connects a number of cameras, for example, or sensors or so. And in any situation, you may start with actually cloud-based processing, where actually you start the feature, for example, depending on the what cloud you are using. You can start first in the cloud, and then when the product becomes real, you can then move it to server, depending on, or leave it in the cloud, depending on the application. Of course, in many situations, you need sensors to provide you with data, as we shall see. There are many tools that you use in artificial intelligence, but and one of them I'm just highlighting is no-code AI that requires no knowledge, let's say, of programming. In most of the cases, for really professional work, you will need to have Python, and then you will need to use libraries. I would say the most important one or dominant one, possibly that you can rely upon, is Python and Keras. And then the rest will appear to you after for specific cases. But these are two important ones that actually you can start with, and maybe you can start with the Google crash course to use them and to learn about them if you like. And in many situations, if you are familiar with Amazon Web Services or Microsoft or Google Cloud or IBM Watson, you can actually use it also to provide you with simple means to program or develop the innovation that you are after. These are just examples of the no-code or low-code applications. You can actually search for it in the internet and use one of them that possibly can suit your particular innovation. So here I'm assuming that someone that has no programming knowledge, of course, to work with artificial intelligence or become an artificial intelligence practitioner is something, and to innovate using artificial intelligence is, let's say, something not really else, but something also possible. So you don't need to be an expert or practitioner or professional AI in order to make innovation using artificial intelligence. You will possibly optimize your service, or a professional or a practitioner will possibly optimize whatever you develop from your idea. But here, these are some examples of low-code, no-code tools that you can use to develop artificial intelligence products or solutions. So actually, this collection is made by Egnar Mar, someone famous writer. So for the time left, we will go through a number of AI innovations in different sectors. So we are going to see application in healthcare, education, agriculture, security, autonomous mobility, transportation, retail, human resources, finance. I think we'll not have time to look at justice and social media, AI in manufacturing, in operations, in media and entertainment, tourism, sports, and technology. So actually, practically, all type of fields, AI has its innovative application, and you can innovate more and more in your work. So everyone in his work can always think, how can I improve? How can I automate? How can I have something to help me to optimize or to make decisions based on knowledge that can save me the effort of looking here and there and so on. In fact, I did not really mention something about ChatGPT. Maybe some of us are using it. Those who are not using it, maybe they can start using it. But I see it helpful. Of course, it's far not yet ready to give answers, clear, accurate answer, unbiased for many of the questions. But it's a very important, good step that can give you something as a human that can actually improve and build upon. And that's really answered the question which always asked in many applications: will AI take over humans? Will it take our jobs? It will not take our jobs, but it will help us in our jobs. And we have to be prepared and ready how to use it. In fact, like many other technologies, this will require some time for some AI experts in different fields to actually give guidelines for everyone how to use AI in his field. Let's look at healthcare. AI innovation in healthcare. Healthcare innovation can be simple as changing the form to check out a patient 5 minutes faster, or to save time, or as complex as immunotherapy that targets specific type of cancer cells. We will say some words about it. So, for example, as we mentioned, that human doctors can have, let's say, 3.5% error when making diagnostics for cancer, while AI may have 7.5, which means that it's having more error. Let's say this study was actually 2.5 years ago. So we don't know really these figures, how far it's improved. But in this study can say that AI plus human makes 0.5% only errors, which actually say that with AI, doctors can actually make better performance, and therefore that's in general AI can ease the work of anyone. So we can always say differentiate between people working and people working with the aid of AI-based products. This is a very important discovery by DeepMind, or AlphaFold, which is DeepMind system, in actually defining how amino acid, the folding of amino acids is resulting in it can actually predict the shape of the protein with very nanometer accuracy, so very high can predict the type. And this discovery actually was fundamental for drug discovery, as we shall see in a later slide. And also we can find that, for example, Neuralink is trying to make a connection of computer to the brain to be able to find analyze and identify the signals that can result, for example, in certain motions, so that they can actually repair, let's say, impaired persons, speech impaired persons, or any type of human impairment. Actually, with this, as Elon Musk is claiming, possibly when it matures enough, technology will, AI-based technology will be able to cure many type of diseases. So as we mentioned, that based, for example, on this discovery of how the folding of amino acid result in defining the shape of protein, then some drug development are actually becoming more possible to focus on addressing the immunity system. Unfortunately, I'm not a specialist, but actually, a Silicon Valley company called Flow Pharma is developing this type of vaccine. As a matter of fact, they call it, but it is really both vaccine and remedy, and that can address the specific shape of a disease, for example, like a virus, or even like a cancer cell, and then it can train the immunity system to recognize this type of cell and only go to destroy these cells. So it will become a medicine that can cure viruses like corona, cure and prevent, and possibly cure different types of cancer. This also actually, with the use of artificial intelligence, can deal with type of problems that include billions of parameters, like in the drugs, and also in other material, to be able to identify relationship between drugs and the molecules, for example, that makes such drugs. So the benefits for healthcare can be just summarized and will reduce human mistakes, help in accurate decision making. In fact, most of these benefits were mentioned even when we were talking 10 and 20 years ago, when we were talking about e-health, which means the use of the internet. Just use electronics and internets and records. Electronic records actually can talk of almost all these advantages. But with the AI, it further improves the capabilities that a previous technology was achieving. We mentioned before that technology moved from e-health to smart health and now to AI-based health, for example. So, and help accurate decision-making, support, and virtual assistant can help the doctor and the patient, help prevention of disease by analyzing how, for example, a disease is spreading, and then can predict when it will happen, and then can take precautions, identify which areas are subject to the disease, or so on. And of course, we have the wearable healthcare technology. And also this, as we mentioned, was also thought of a long time ago with internet, with mobile, with smart type of, but with artificial intelligence, it will give capabilities more to do other things. For example, one good application one of the companies here in Dubai is developing is to be able to look at the patient and see if he has a pain, for example, so that the doctor can actually make take precaution without, for example, a dentist then can identify if there is instead of saying then he can know already that he has a pain, especially if he cannot talk, and Other, for example, application monitoring, for example, the newborn babies for type of danger situation that can happen to them, and automatically call for the nurses instead of having a nurse all the time observing, which is not the case. Then it can actually, through the teaching the machine the type of alarms that can happen, then it can make this automatically. So such type of things can be helpful. In education, of course, there are also many applications. One of them is GPT, as we just mentioned, and can actually help student actually a tutor is like a private tutor, for example, for a student that he can ask him questions that may not be easy to ask in a classroom, for example. Ensure access to education for students with special needs, then a more customized solution can be made for any student with special needs. And of course, lately there are efforts to develop, to monitor the student attention and detect emotion reaction, to see if he understands or really is concentrating or so on. And also, for example, for online learning, because the tutor is not aware of the status of the student, and so they can say the degree of attention and so on. And there are many other applications also that help the student to access, for example, more learning material, and to personalize, as you mentioned, more for every the lessons for the student, and also it can help, of course, the administration of the education system to do a lot of things automatically. In agriculture, also can AI capitalized in interpreting nature signals like plant photosynthesis process or other responses to any external stimulus. This is actually research work done by Indian Institute of Technology, but generally precision farming, where actually you can analyze where weeds are growing, and precise AI-powered pesticide applications. And you have also autonomous tractors, for example, and AI bots that can help harvest crops at higher volume and faster pace than human. AI application in security, there are many. I don't think, although I'm not sure whether I can use the 15 minutes delay of the presentation, but okay, I hope so. We have in different fields. We are just going to focus, for example, cybersecurity, cyber child abuse, lost child discovery, COVID rules enforcement, perimeter intrusion and critical infrastructure protection, autonomous vehicles and robots and drones in dangerous situations, traffic law enforcement, access control to enterprises, weapon detection, country holistic security. So actually, practically by the use of computer vision and facial recognition, you can identify, for example, lost childs in a crowd and detect them, and possibly in airports and places like this, and then can identify them. And here, this is just a video showing a perimeter protection using LiDAR technology. And the camera, we didn't talk about LiDAR here. Maybe I will talk about it in a later slide. But LiDAR as a sensor, IoT is very much related to artificial intelligence because it provides the data that artificial intelligence is using to perform its function. So here we have two main type of IoT devices, the camera and the LiDAR sensor. LiDAR stands for light detection and ranging, similar to radar, which is radio detection and ranging, but it was based on in light, and actually it gives very accurate positioning of the objects. So it, as you can see, it tracks the object like this, and then it can trigger the camera to take a picture if it gets out when it gets to the area covered by the camera. As we mentioned, of course, the autonomous vehicle can be used in security applications and for access control and for weapon detection, simply by just programming for the different shapes of different shapes of the weapon. Then the system can detect them through normal cameras or X-rays. In autonomous mobility, we have different types of autonomous vehicle for the autonomous cargo vehicle or autonomous delivery vehicle or autonomous chair and autonomous car, of course, and autonomous tractor, as we mentioned, and in the future, autonomous flying car. The principle of autonomous actually is using sensors to provide sensing capability to be able to perceive the environment of the vehicle, and then knowing also the locations and the mapping of the area, feeding the processor of the car, for example, with the map of the area, 3D map of the area. Then the car exactly knows where it stands in the area, and then with the detectors can see the environment, what's surrounding it. Then it can make planning, and it can also, by knowing the environment accurately through, for example, use of LiDAR, which gives us centimeter accuracy of all the objects around the car. Then by making such awareness of the car, of the environment, then it can make prediction of what action. For example, someone, a human, and standing in front of the traffic signal, so it may predict that by mistake he can cross the street, for example. The quality of driving is really the quality of how good the prediction the driver is predicting around it. So a regular driver would require high perception, can perceive what's happening, and can predict, not only predict what's happening, but also to make himself predictable to other drivers. So all this functionality can be implemented in a car, and then with that, it makes planning for the route and so on. For transportation, this is just an example of also a camera taking a picture of the drivers, and then can detect the driver violation if he's wearing a belt, or if he's eating or using the mobile and so on, and can make a fine. Of course, other tools can detect also speed violations and other type of violations, and other capabilities also can be made to control the traffic. Well, in retail, generally, it also knowing about the customer behavior and what he likes and so on, then we can segment the type of customer, can identify actually how customer like a product, and also it can be in the service. You can have chatbots to answer customer complaint, and of course, Chat GPT will improve very much chatbots for the retail to be more capable of providing better service. And then human resources, hiring new employees, for example, it can, with the data about the employees, it can more or less help the human resource to make selection, hopefully not so biased about candidates, so it can give a preliminary guidelines, and then of course the human will make the final decision. And it can predict which employees are likely to churn, for example. All this actually by making, identifying data about the employees and putting them into tables, and from the knowledge of the past data, you can see that the employee who is subject to this and that, maybe tens of parameters, is leaving. So we can possibly get pattern about those who leave, and then if we have an employee with certain characteristics, we can say that, oh, this employee may be leaving. And the same thing, of course, can apply for retail when we are defining that this customer like that, this and that and that and that and that. So he may likely purchase this product, for example. Then we can focus and show him this product, for example. In finance, of course, applications it can, of course, automate certain applications, especially with robotic process automation, and can also predict which customer can have loan or not have loan, the quality of customers by actually having tables including the different characteristics and merits and features of the customer. Then it can easily say that this customer with this and that and that and that features, then he's a good one, or this and so on. Of course, it can help in predicting the stock market, how it's moving up and down and things like that. And help the bank to comply with many things that required by regulation. In conclusion, AI is an evolution of ICT technology, especially enabled by big data, broadband, fiber and 5G, and possibly 6G in the future, cloud services, IoT, sensor, large processing power, hopefully in the future maybe quantum computing, and new algorithms, highly developed algorithms. AI is a tool empowering people and organizations to achieve their strategic goals, as well as better understanding our cities and societies. Different AI capabilities and tools are available to innovate and create products and solutions in all verticals, especially healthcare, education, security, and many more can still be innovated. Thank you very much. Any question? Any question about anything related to AI use for innovating new products or services or solutions?